Some are too massive to be planets, yet too small to become stars. Trapped between two worlds, these mysterious objects have puzzled astronomers for decades. Hidden between the smallest stars and the largest planets lies one of the universe's strangest objects, brown dwarfs, often called failed stars. They are neither true stars nor ordinary planets. They glow faintly in the darkness, wandering through space like cosmic ghosts, carrying secrets about how stars and planets are formed. Today, we're exploring these mysterious celestial bodies, comparing them with stars and planets, and discovering why scientists believe brown dwarfs are one of the most fascinating objects in the universe. To understand brown dwarfs, we first need to understand how stars are born. Every star begins inside enormous clouds of gas and dust called molecular clouds. Over millions of years, gravity pulls this material together until the pressure and temperature at the center become incredibly high. When the core reaches approximately 10 million degrees Celsius, hydrogen atoms begin to fuse into helium. This process, known as nuclear fusion, releases enormous amounts of energy, allowing a star to shine for billions of years. But sometimes, nature doesn't gather enough material. The collapsing cloud stops growing too soon. The object becomes massive enough to form a glowing sphere, but not massive enough to ignite sustained hydrogen fusion. That object is called a brown dwarf, a star that almost existed. Brown dwarfs have masses between about 13 and 80 times the mass of Jupiter. This places them in a fascinating middle ground. A planet like Jupiter isn't massive enough to produce any fusion, while a true star like our Sun easily sustains hydrogen fusion. Brown dwarfs sit between these two extremes. They are too heavy to be considered planets, but too light to become real stars. This unique position makes them one of astronomy's most important missing links, helping scientists understand where planets end and stars begin. One of the biggest differences between brown dwarfs and ordinary stars is the way they generate energy. A true star continuously fuses hydrogen into helium, producing immense light and heat throughout most of its lifetime. Brown dwarfs cannot maintain this process because their cores never become hot enough. However, the largest brown dwarfs can briefly fuse deuterium, a rare form of hydrogen, and the most massive ones may even fuse small amounts of lithium early in their lives. But these reactions last only a short time. Once the fuel runs out, the brown dwarf slowly cools and fades over billions of years, becoming darker and colder as time passes. Compared to planets, brown dwarfs are equally mysterious. Jupiter, despite being the largest planet in our solar system, has only about 1,000th the mass of the Sun. Even if Jupiter were several times larger, it still wouldn't become a star because it lacks enough mass. Brown dwarfs, on the other hand, are far more massive than Jupiter. They generate heat from gravitational contraction and, in some cases, temporary fusion reactions. Unlike planets, they usually form directly from collapsing clouds of gas, just like stars do. This means brown dwarfs are born more like stars than planets, even though they resemble giant planets in appearance. So why are they called brown dwarfs if many of them don't actually look brown? The name is somewhat misleading. Most brown dwarfs would appear dark red, deep orange, purple, or even magenta if our eyes could see them clearly. Many emit most of their energy in infrared light, which is invisible to humans. This is one reason brown dwarfs remained hidden from astronomers for so long. Before advanced infrared telescopes were developed, these objects were almost impossible to detect because they emit very little visible light. Their temperatures vary dramatically depending on age and mass. Young brown dwarfs can reach temperatures of over 2,000 degrees Celsius, glowing with a dim reddish light. Older ones gradually cool to just a few hundred degrees, with some even approaching temperatures similar to Earth's hottest deserts. Scientists classify them into spectral types M, L, T, and Y, with Y-type brown dwarfs being among the coldest free-floating objects ever discovered in space. Some Y dwarfs are cooler than boiling water, making them incredibly unusual cosmic objects. One fascinating question is whether brown dwarfs have weather. Surprisingly, the answer is yes. observations reveal enormous storms, swirling cloud systems, and powerful winds in their atmospheres. Instead of water clouds like Earth, brown dwarfs may contain clouds made of molten iron, silicate minerals, or tiny grains of sand. Imagine rain made from liquid metal falling beneath skies filled with glowing mineral clouds. These alien weather systems are unlike anything found anywhere in our solar system. Scientists have also discovered that some brown dwarfs possess powerful magnetic fields, capable of producing spectacular auroras, similar to Earth's northern lights, but vastly more energetic. Radio telescopes have detected bursts of radio waves coming from several brown dwarfs, suggesting intense magnetic activity. These invisible light shows may illuminate their atmospheres with brilliant colors that human eyes could never directly observe. Another surprising discovery is that brown dwarfs can have their own planetary systems. Astronomers have found planets orbiting several brown dwarfs, proving that even failed stars can become miniature solar systems. Imagine standing on a planet orbiting a brown dwarf. Instead of a bright yellow sun, your sky would be illuminated by a faint glowing red object, creating an endless twilight unlike anything on Earth. Brown dwarfs are incredibly common throughout the Milky Way. Scientists estimate there may be billions of them scattered across our galaxy, yet they remain difficult to find because they are so dim. Modern observatories such as infrared space telescopes have dramatically increased the number of known brown dwarfs, helping astronomers map these hidden worlds and understand the true population of objects in our galaxy. Perhaps the most famous brown dwarf system is Luhman 16, located only about 6.5 light-years from Earth, making it one of our closest cosmic neighbors. This system contains two brown dwarfs orbiting each other, providing astronomers with an extraordinary laboratory for studying failed stars up close. Observations have revealed changing cloud patterns and weather systems moving across their surfaces, offering a glimpse into atmospheric processes unlike those found anywhere else. Brown dwarfs also help scientists answer one of astronomy's greatest questions: how do stars and planets form? Because they share characteristics with both, they act as a bridge between these two classes of objects. By studying brown dwarfs, astronomers gain valuable insights into the earliest stages of stellar evolution, planetary formation, and even the conditions that existed when our own solar system was born. So, are brown dwarfs failures? Not really. The nickname failed stars simply reflects that they never reached the conditions needed for sustained hydrogen fusion. In reality, they are successful cosmic objects with their own unique identity. They challenge our definitions, blur the line between stars and planets, and remind us that nature rarely fits into simple categories. And with that, our journey into the mysterious world of brown dwarfs comes to an end. These silent cosmic wanderers remind us that the universe isn't defined only by the brightest stars, but also by the hidden objects that quietly shape our understanding of space and time. Every new discovery brings us one step closer to unlocking the secrets of the cosmos. And who knows, perhaps the next great mystery is already waiting to be found. If you enjoyed exploring this incredible story, don't forget to like this video, share it with your friends and fellow space enthusiasts, and leave a comment below telling us which cosmic mystery you'd like to explore next. And if you're fascinated by the mysteries of the universe, subscribe to the channel and turn on the notification bell so you never miss our next journey into the unknown. Until next time, keep looking up, because the universe always has another secret waiting to be discovered. Thanks for watching.